Good day to all. Today we are going to see about the transducer. See what is the transducer. Transducer is a device which converts a primary form of energy into a corresponding signal with a different energy form. What is the primary energy form? It's nothing but the mechanical, thermal, electromagnetic, optical, chemical, etc. We can say those are primary energy forms. These energy forms converts with the different form, that's called transducer. Then sensor, for example we can say thermometer is also one of the sensor. What is a sensor? A device that detects or measures a signal or stimulates. If you want to sense something, if thermometer, what is the use of this thermometer? It is used to find out the temperature. Likewise, the device we can detect or measure for particular applications. Then acquires the information from the real world. As I said before, if you want to take a temperature in our body, thermometer will use. With the thermometer, we know about our body temperature likewise. Then actuators. What is actuators? A device that generates a signal or simulates. That's called the actuators. See, in this real world, sensor and intelligent feedback system, then actuators. Because if you want to sense something, here we'll use sensor, then sensor will give some feedback. After that feedback, the actuator, this actuator is used to actuate something, want to move something like that. We will use this transducer, sensors, actuators in our real world. That's we denoted simply here. Then the sensor systems, typically interested in electronic sensor that converts desired parameter into electrically measurable signal. That is the electronic sensor. Generally, the electronic sensor are two types. Which one is a primary transducer and the secondary transducer. What is the meaning of primary transducer? Change the real world parameter into a electrical signal. The secondary transducer which converts electrical signal into analog or digital values. Okay, you can see this normal diagram: primary transducer, an analog signal, secondary transducer, and useful values. We'll get that. Then the typical electronic sensor system, how it will be. If we are giving input signal to the sensor, then this sensor for analog or digital, it will move up to microcontroller, which is a signal processing communication. Then it will go for network display. Then we will use. This is the typical electronic sensor. Then the example of electronic sensor systems are components vary with the applications. First of all, digital sensor with an instrument, and then microcontroller, and then signal timing, data storage, and analog sensor analyzed by a PC. PC is nothing but a personal computer. Here you can see sensor. This is Mamse, which is signal timing memory used for display. If we are giving the input from that keyboard, see we are typing the keyboard in our system, we'll type something. This keyboard will go for a micro computer, we can say Mamse in signal timing. Then it will again display to us, right? This is the analog sensor analyzed by the PC. Then multiple sensor displayed by the over internet, which is sensor. Then the sensor interface analog to digital and the communication signal processing For example, RS32, that is also one of the communication card we'll use in that electronic system. Likewise, we'll see here. Then see the sensor processor communications with the help of sensor bus and PC. Then again sensor bus, we will have a sensor communication. This is the example of electronic sensor system. Then we'll know about the primary transducer. See, conventional transducers, it is large but generally reliable based on the older technology. For example, thermocouple compass magnetic compass we used for the direction, and that is also, and the temperature difference we will find out the thermocouple for temperature distance. These are the conventional transducers. And microelectronic sensor, which is a millimeter sized, highly sensitive and less robust. The example of that microelectronic sensors are millimeter sized, which one? The photodiode and the phototransistor. This photon energy, light, infrared detectors, proximity and intrusion alarms. Then piezo resistive pressure sensor, which is nothing but air or fluid pressure, micro accelerometer, vibration and velocity contrast, chemical sensor, for example O2 and CO2, CI, nitrates. These are all the explosive things. And DNA arrays, used for DNA test, like that DNA sequences. Example of that primary transducers are light sensor. See, we can detect a sensor with the light. That is a photoconductor. Light is del R. With the difference of del R. Del R is nothing but the resistance. Del R means differentiation of resistance. With the differentiation of resistance, we will find out the photoconductor. See, this photoconductor, light sensitive semiconductor resistor with the graph of resistance and the light level. See, if the resistance value is decreased, light also will increase. That's the thing here. Then photodiode. Photodiode is used for detecting with the help of current. You know, this R already we said resistance, and I here is current. So with the help of this current we will find out the photodiode. Here you can see the graph between the current I and the voltage. First the current is decreased, and again will the current decrease from the voltage to current, membrane pressures, resistive pressure and capacitive pressures. I equal to I naught into exponential of e to the power of e by kt minus 1 into minus of I lambda, which is I lambda is equal to proportion to the light level. You can see here the photoresistance is here, and this is a constant pressure will occur. If you are give a pressure here, means the constant pressure will occur over here for time period t, then it will reflect to the C. So C is equal to sigma A divided by T. This is the example of primary transducers. For this one, we'll already seen the main advantage of this transducer in conventional transducer. It is large, generally reliable based on that older technology. Here we have to mention this one is the older technology. Here in microelectronic sensor, this is a millimeter sized one, high sensitive and less robust. And these are the examples for that primary and secondary transducers. as well as this also with the differentiation of resistance will find out the photoconductor light sensor. Differentiation of current will find out the photodiode sensor. Thank you.